Okay, so maybe we can get started. Welcome everyone, and thanks for staying till the last session. I know some kind of fatigue has set in, so we will try to wrap this up on time at least. I know people have flights to catch as well. So I think of this as a kind of wrap-up session where we can discuss what we have learned so far and how we can take this forward. And just to guide this discussion, I just wrote down a few points where we can anchor our discussion on. So this is the panel. I'm not going to introduce them. We know all of them, and we thank them for agreeing to be on the panel on such a short notice. The idea would be that we can take up, basically there are 2 points. We can take 1 point at a time. And I will first request the panel members to share their thoughts for a couple of minutes or so, and then open it up for your comments. So we would really like to make it very inclusive. So feel free to air your thoughts with us. And we are trying to keep some notes as well. I mean, if the discussion indeed turns out to be very interesting, we'll share the summary with all of you, which probably can be used in the near future. So we start with the kind of title and the theme of the conference. That is to say, what is the way forward for having synergies or commensalities between these two apparently disjoint communities, but actually not, which is the radio continuum and 21 centimeter cosmology. And when I say 21 centimeter cosmology, I include both the EOR and the post reionization part. And we had people from both here. Just to set some context, the radio continuum community, at least in India, has been one of the kind of strongest and has been working since the beginning of radio astronomy in the country, so to speak. It's a large community. And 21 centimeter cosmology community is probably the other end, where it's relatively new community with a lot of young people working on it. Again, it has grown very fast. The question is, we should find ways to have synergies between them because there are a lot of scopes. So before opening it up, may I ask what the panel members feel? So shall we start from that side, Matthias? Yes. The places where we can synergize and the way to go forward, basically.
So would you like to subdivide into A, B, or?
It's up to you. A, B are just examples. You can have your own thoughts as well. Yeah.
So first of all, I think synergies is we should come to those nice locations over here for conferences. I think that is an ideal spot, and I think I hope that is the start of a series of these kind of conferences to do more on that. But I could imagine what then maybe in future conferences is, let's say, tackled a bit more is kind of the middle ground between the H1 and the Continuum survey. So I think so. What is exactly, for instance, I may ask the H1 community now: are you interested in our foregrounds, or is it do you go to a parameter space where the foreground is completely irrelevant for you? So that is not entirely clear to me. If you need a perfect modeling, if I look at LOFA, if we have these huge, what is the record holder now, 8 megaparsec giant radio galaxies, do we have to model that? Do we have to subtract that? That you can do your, or would that make your H1 science better? Or is that something detailed? It's just some radio galaxy in the sky, just very huge. I had a discussion yesterday, so that is not clear to me, and I would really appreciate to learn that at such a conference over here. Assume what you know from the Millennium simulation or something like that, that this cosmic web is all glowing in synchrotron, all filled by AGN, all filled by Brunetti-Watzer-like turbulence, accelerated electrons, small scale dynamo, amplified fields. Everything is glowing in synchrotron. That then has the structure of the cosmic web, and it would be in the foreground of what you try to find at low frequencies. Would that disturb you? Yes or no? So right now at the conference, I try from my internal eye, I try to review a bit the talks, So at least I don't recall the answer, if the answer was given. So maybe I did not really fully understood that. But what I could imagine is that one really has a dedicated session or a dedicated situation where one say, okay, put your question and now we try to answer that. I think that is when you do something interdisciplinary like this, it's always necessary. So when I talk about relics, I think everybody knows a relic perfectly.
Yeah.
But that might not be true. So I might imply something what is incorrect. And the same is, you may assume that I exactly know what these strange wedge with blue and yellow, what it is, but I may not know. So therefore, one has to have this introduction where these things and what this, let's say, what is exactly, what mass is behind it, or what is relevant for that, that is explained. And I think that would be helpful to understand these things better. And to know what is useful for that community. Maybe my last point, and then I stop and give it, is I think we had a discussion at other places. I think that there must be an enormous synergy, since the Continuum community would like to stare for an infinite amount of time at one place on sky to get the number counts correct, to do something. If I understand correctly, the H1 community is doing exactly the same. I am very, very confident that, let's say, a telescope like SKA would benefit if those observations could be done as a commensal observation. So if you can say, okay, we can agree on one field, what would be useful for both of us.
Okay, thanks. So let's hear from others before opening it up. Yeah, Ruta, you can.
Yeah, so Continuum surveys generally, either try to do wide surveys or very deep but narrow field surveys. So EOR fields are going to be something extremely deep. So definitely the Continuum community would think of those as extremely deep fields. So it would be good to understand what are the things right now missing, or what would be good for the EOR community to know about the Continuum sources, which can be learned either from the wide all sky kind of surveys versus deep narrow field surveys. And then the multi-frequency information, how does it fold into the EOR, whether everything only at the low frequencies matters, or there's something to be gained from higher frequencies as well. And then in Continuum surveys, people have tried to mine the archives for all kinds of transients. All of these are going to be present in the data that we record. So at what level would they matter for the EOR fields? And yeah, maybe something unknown might come out from deep fields such as EOR. Yeah, so we would like to know what is the understanding that is needed from the Continuum surveys, which will complement the EOR studies.
Thanks, Ruta. So we can pass it to Garrett. Maybe you can also take their comments into
account
while
so,
shaping yours.
Actually, it resonates quite well with what I wrote down before. So okay, so for the EOR observations, we do need to subtract the foreground sources, and then in LOFAR we do this, I guess, at different levels. So the brightest ones we model individually, and that consists of various components. So then, yes, we're interested in their structure for those, because we need to model, and we need to model actually at a higher resolution than we're doing the EOR measurements, because yeah, otherwise you're left with residuals. Basically, you need to be sort of sub-pixel or whatever you want to call it in resolution there. But then the fainter ones, I guess at some level, we group them together in some sort of background and remove them. So it's only up to a certain amount. But I don't know, actually in practice, I think we made those models just from our own observations. The question is if those models, the various components, are interesting for the Continuum community. I can't answer that. Maybe Leon or Florian can comment about that. So also for LOFA, I know that the deep observations have helped for the UR field. Some of this was actually useful for the surveys, so the continuum surveys. But for SKA, the situation is a bit difficult because if I remember, 10 minutes, what was it, 15 minutes?
Yeah.
After 15 minutes, you're confusion limited on all the baselines in SK low. So there, you know, and we're gonna go for, well, 100 hours, maybe 1,000 hours. So that's not gonna work. Not at the low frequencies. Like I said, mid, it's a different story, but then you know, I don't know, it's a different set of observations, essentially. Yeah, I don't know. I think this is half response to what was said here.
Yeah. And Sami, since you have been working on your fields and you are also collaborating a bit with so-called continuum.
So actually,
scientists,
same thing we are, whatever the smooth component we are removing, but itself it is an interesting subject actually. Some of the things we have been doing is that just like a statistical study, but actual modeling, I think there are no, in the low frequency, we are not doing that much. So one of the interesting things that we are interested, but we are not, we have to do is that detailed modeling of the electron density and the magnetic field. That will be itself, it is also beneficial for the UR community and also for the continuum science. So that we have, mainly what we are doing now is just some smooth component of the foreground and removing them. But it will be good at the low frequency. There are only few observations to constrain the electron density and the magnetic field of the galactic synchrotron emission. So it will be, so we are interested in doing that also. Some modeling and then compare with the observation and constrain some physical parameters of the galactic synchrotron. So that will also be interesting, and yeah, and also for the continuum and EOR. So yeah.
If I understand correctly, are you saying the knowledge of electron density and magnetic field also be interesting, I mean, important for the EOR science as well, or are
detailed modeling of that? For subtraction, I think we don't need that much, just but it should be interesting for the EOR means continuum science.
Okay.
How the electron density changes as a function of positions and the magnet. Also, it is coupled. We can't density and the magnetic field line of sight component are coupled in that intensity, but it will give some insight of that physical properties. So that will be interesting study to do that. But yeah.
Okay. Thanks, everyone. So maybe we can see if, people have response or questions to the panelists.
Yeah, maybe I can respond to some of this. So I think in terms of the models, right? Of course, we by 21 centimeters cosmology is all sky imaging, right? I mean, we need a model of the entire sky to a certain level, but the two important aspects here. One is we need a model for calibration. And that model is never going to be perfect, right? We're never going to go all down to the milli and the micro Jansky, right? Forget about it. That's also computationally simply not feasible for us to include everything, right? So we go down to a certain level, and then we sort of make sure that our gain solutions are smooth enough that it's sort of whatever is left there and these little wiggles are sort of smoothed over, right? So that's at that calibration step. Right, and then we effectively don't use those long baselines, right? We're really going to the short baselines, and we lose effectively all of the information, right, on this very high resolution. And then we need to subtract these models. So the better these models are, I mean, the better it is for us. I think Harold was saying this, right? We need some of the bright sources you need at much higher resolution than what you can actually resolve with your baseline. So even the smallest differences there are very important, especially on the very bright sources like CAS A, Cygnus A, etc. These need to be modeled in excruciating detail. But the rest is at those very let's say short baselines. It's just a diffuse mass. It's diffuse emission of the galaxy, confusion noise. It's all mixed together, and there we use effective models. So I think where the synergy also could be is that we are very much interested in the short baselines, and many of the community is very much interested in the longer baselines and so on, right? And right? To build this entire sky model, let's say, of from diffuse, from the shortest to the longer baseline, I think that would be very interesting, right? To build a single map that goes all the way from very well calibrated short baselines, and we're very good at doing that as a 21 centimeter community, but we're maybe not as good in building good images and models of the more bright and compact sources. I think something, of course, this is a community, a continuum question, but there's something called polarization as well,
Yes.
right? It might be for many people also extremely interesting in a very different community from us. And for us, again, it's sort of nuisance that we need to model and maybe get rid of as well. So I can see, I mean, and even out of what we did in the past, what Wiebe Jelic and others have done, right, is start up a whole new study of the polarized galactic foregrounds from our observations effectively. So I can see a lot of synergy there as well. So it's a very complicated thing. I don't think necessarily the models we built of the compact sources are of any interest to most of you. But the other way around is very interesting if there are going to be very long baseline observations of compact sources. And it shouldn't just be continuous, it is all right. We need very accurate spectral models as well for all of these sources, right? We can't just say, okay, it's a power law, right? So we need that as well. I think that would be very interesting. It's certainly something that we hope we don't have to do ourselves. So maybe I should stop here.
So yeah, I think it answers Matthias's initial question. So yeah, go ahead.
Yeah, so you mean that you have spectral index map of the detailed map of the extended structures with high resolution. But the catch will be that probably with higher resolutions, you have also less baseline at the larger baseline places. And the maps may have deconvolution errors built in. And once you use those, then even at the lower baselines, those errors may affect you. So it is.
So we tested this actually recently by sort of you're absolutely right? I mean, especially at the longer baselines, you get the sort of mode mixing of these bright sources and then getting their spectral indices as functional. Like maybe there are some extended stuff around it. So what we do is sort of force spectral index modeling where we do an iterative spatial and then spectral modeling, and that stabilizes the solutions. We show that we can actually model those sources much more accurately. And when we put those models then into a 21 centimeter simulation, let's say, just to see what the effect is, we really see that that improves things. But if you don't do it, if you just try to make you have your images with their point spread function and try to get the spectral index map, it's all over the place. So you have to think about it very carefully. Yeah.
Yeah, you could do
So I have one question concerning SKA. You said after 15 minutes, you're at confusion limit. So if I consider the history, so in LOFA, so in first meetings I attended, the UR doesn't need international baseline, so not necessary at all. Then I recall with Gerde Braun, I think it was in Amsterdam, so that he showed, yeah, maybe just for calibration, we may need some international baselines. So is it, could it happen that for SKA, the EUR also realized at some point these baselines are too short since we cannot model disturbing sources good enough? If yes, I think we should team up and should push for longer baselines which come before SKA 2.
It's a very, very good point. So it does help if you have those international, if you can, the brightest sources. Well, first of all, we want to look for fields where we are not bothered by the brightest sources. That's number one. It's a lesson we learned from LOFAR, and I think MWA, everybody learned it, right? The first fields we chose were not always the best fields because we didn't have that knowledge, right? We need to avoid those very, very bright sources running through our side lobes and causing havoc. But okay, sometimes we have those bright sources, we can't get rid of them. Then it does help in the simulations if you have a much higher resolution model in how we analyze it, and we see this in simulations. But when we actually look at the observations and use these very high resolution, we see no difference whatsoever in the power spectrum results, which tells us, right, at the moment we're not dominated by errors in the models of the sources, but we're dominated by errors in the beam, in the gains, in the direction-dependent gains. So it does help. Ultimately, if we can get the beams under control, then I think the next gain is to be made in better sky models again.
But wouldn't you need the long baselines to get that model correct? In simulations, okay, you can model it correctly. But if you don't know, you have to measure it. So in order to get your spectral components and everything correct, to measure it and subtract it correctly?
So I think you have to think about it carefully, right? We know that you feel structure down to basically the full width half maximum of the source divided by square root of the signal to noise. So for each source, in principle, you could say up to which baseline, which signal to noise, am I starting to feel that structure? We've not done that, but in principle, you can calculate, okay, do I need a high resolution model for this particular source before I start feeling that structure? So we haven't done that. And I think for these very, very bright sources, probably we can't go around the fact that we need better models. But I can't say it 100% sure because I think at the moment we are completely dominated by other errors. So in the simulations we see improvements, but in reality we don't.
I think, so when the SK was designed, it wasn't, I think the longest baselines in SK low were not set because the UR community said it's enough with 70 kilometers. I don't know, I think it's 70, right? This was essentially set by what fitted in Bulardi Station, which is the land area that CSIRO could acquire. And so in that sense, it wasn't, you know, it was not that we said it's enough with 70.
Costs went down.
Yeah,
So,
yeah,
that
I guess
is true,
acquiring
yes.
the land was. I had a wild idea, which so maybe one. So is there any interesting? So when you're confusion limited, you could say it's some sort of projected intensity mapping. Is there interesting information in that? If you can separate it from the diffuse foregrounds. So this would be sort of, I don't know, it's projected, so there's no redshift information, but it's still, there will be fluctuations in that.
Yeah. I think what we saw in Mark's talk, so essentially redshift integration of those lines, we will essentially be able to generate. So he showed, right, that the correlation between H1 content and, sorry, the radio galaxies and the star forming radio galaxies. In redshift integrated version of those lines might be produced. So that might produce some sort of threshold or what galaxies, which galaxies can produce star, and which radio bright galaxies will produce stars, etc. Some sort of correlation.
But these galaxies will be like, you know, the spectrum will be the smooth, right? So there will be some sort of like you can spectrally model and then subtract it out, correct? No?
Where you are, you mean? Yeah, but I'm just, okay, my question is more, if you would somehow from these very deep observations extract the confusion sky, and you take out the bright, the resolved bright radio galaxies, somehow get rid of the galactic foreground, which is also, of course, fills the entire sky. Is there interesting information in that? I don't know. Okay. Something to think
about.
Yeah, I think that needs a lot of study to understand what the interferometer does to that signal, what you get. It's not so easy, not a straightforward inversion. But it's an interesting idea to do that.
The correlation of the confusion sky will be kind of 4-point functions, right? Because it's already squared at that place, giving the noise. And then if you correlate it at with some other place, like kind of intensity interferometry, one can look at what may come up from that, but
I don't know. I mean, I also wanted to ask Abhirup or someone about the Indian experience. So we started mostly as a 21 centimeter group going to observe, but over the years we have felt the need to actually connect with the continuum community, understand polarization and things like that, and we have tried to reach out, right? So maybe if you can.
I mean, we started with GMRT band 3 because band 2 was not available that time. So purposefully we were stuck with band 3 because that was available, and we end up doing a lot of papers with foreground science effectively. But then again, the polarization was not available in band 3 that time. Now it is starting to happen. But now we have gone to Stokes High again to band 2. So I think it's a step by step. I mean, unless you get your Stokes High correct to get a full polarized sky is a bit difficult thing to do. But now I think with the understanding which we are getting, what is the polarization leakage intrinsic to the sky, what is belongs to the beam or the instrument, those things can be really well tackled, and with the expertise which the Continuum group has in the intrinsic sky polarization, that can be a very nice synergy which can automatically get translated or can be shared. That's a good synergy, I think.
Of course, what hasn't been mentioned yet is the 21 centimeter forest,
Yes.
right? So if you find a very bright radio galaxy, you can do this 21 centimeter absorption study against it. But then you have to find that radio galaxy first, and that's more continuum science, you could argue.
Yeah. True. So, yeah, go ahead.
Regarding the foreground thing, so actually, I don't know if someone is using that foreground polarized model for the calibrations. At the low baseline, it affects actually a lot. If it not including in the calibration model, the foreground polarized foreground. So actually, we using just Stokes High model for the calibrations also. But just I want to know if someone is using the polarized foreground model. I have seen some of the literature that affects the low baseline some. So that's, I think we should include the foreground polarized model also in the calibrations.
It depends on observation, right? Also, if you're having a full polar data, then only it kind of.
Yeah. So, yeah, sorry, carry on. I wanted to get the backbenchers involved if they can. No, please go ahead.
Yeah, backbenchers are needed. Since we are coming to this calibration, and I think so Oleg's talk was, as usual, intriguing this time, so that when you look at your calibration imaging, it may happen that you have a satellite in your field of view. And I think that is at least a few people in LOFA, they are pretty bothered by the fact that Starlink is not only emitting in the band it should. It is only emitting in other bands, and they are not doing anything against it. And if the number of satellites increases as indicated, that may become a real issue. And I think in that sense, we are all in the same boat, that we have to learn how to live with that and use all our political power we have to put some pressure there that maybe the emission is at least only in the agreed bands and not somewhere else. But I think in practical terms, we have to learn how to, maybe there must be a database where you can find all satellites with all possible emissions. When you do the calibration, that you know, today I have 5 satellites in my field of view and I have to take care of that.
So we wrote a paper on this, not specifically on Starlink, but on what's happening over low-far LBA. And right, you see airplanes, you see all kinds of stuff coming over, you see flickering on the horizon, right? We made this movie, I actually showed it, but didn't really point it out in my talk. So, and then we showed that if you actually go to the image domain, it's the same as ground plane RFI, right? It's very sort of scattered and all over the place in maybe your visibilities, maybe in a power spectrum. But if you actually transform to the space where that signal lives, right, which is the ground plane, for example, right, it's a couple of points. And the same, right, if you have something flying over, it's a point in the sky, but it might be a horrible thing in your UV domain, in your power spectrum. So So what we showed in that paper is if you actually track those satellites, right, and basically put little masks on them and then transform back and ask yourself, that was at the level that we saw, right? Does that affect the EOR signal? We showed it doesn't. Because airplanes at least fly every day at slightly different tracks, right? They're not always in the same place. Satellites might be different, right? They come maybe over the same place day after day. So that, in that sense, what was left sort of adds up incoherently and sort of averages down. But I think we have to think I'm less optimistic that we can convince the Elon Musks of this world, especially after the past few months, right? That he has any, maybe this is recorded, I don't know, maybe on one of his systems. I'm very afraid, right, that commercial things will take over here and that we have to develop these sort of techniques, very smart techniques that sort of mitigate things in the domain where the signal is strong. It's sort of what Oleg also showed, right? We have to look at the time varying sky and make sure that we block out those satellites or whatever goes over and then transform back to the domain where we're interested in. So I think a lot of work in the coming years needs to go into these mitigation techniques.
Just a couple of comments on that. The first about your comment whether there's a database where you can track satellites in the sky. Indeed, that does exist, and we use it at GMRT to make a map of all satellites visible in the sky which are operating in our frequency range. And we have software which warns you when you're observing is going to cross a satellite path, and it gives you that information post facto also along with your data files. So that's possible if it is useful. So you seem to indicate that maybe it's not going to be that useful to have the specific paths of the satellites, but it's possible to get them.
Well, I mean, it depends, right? I mean, I think we're now still in a regime that if you have a not too wide field of view instrument, right, there might be a satellite now and then. I think in the future, whatever we look, we'll have multiple satellites in there all the time. And then we're in a very different regime. We can't just throw that data away anymore. We'll have to, right, mitigate this. And the question is, yeah, I mean, for us, I mean, coming back to the 21 centimeter community, everything that's sort of left over and is incoherent averages down, everything that's coherent adds up, right? So if that satellite come exactly the same path from the same UT or LST or whatever, right, it will add up the residuals over time. And that's what I'm most worried about.
My other comment is SKA is trying very hard to basically work out a solution with Starlink that they switch off while they are flying over the SK sites. I'm not sure if they're going to win that one, but even if they do, I agree that it's a losing battle. I mean,
everybody loses the internet in Australia right at that moment.
So that discussion is going on, and apparently it's not a completely it's possible.
Yeah.
And so it's not that Starlink is completely rejecting that as out of hand. So, but again, there will be others coming up with other satellite constellations. So I think it is a losing battle in trying to control this at the source, though we should still work on it. And we have to come up with clever techniques to handle it in the data.
Yeah.
So, yeah, so, okay. And I want to go into the next topic, please go ahead.
Yeah, so one thing, like we are discussing about foregrounds, but I think like more important, I guess, how well do we know the instrument? Because like, I think within last 2 or 3 months ago, Cavendish group showed that if you have a full simulation of the embedded SK beam, like there is a crosstalk effect and all the K modes are gone, like completely dominated by foregrounds. And it is also 2 meter high, so it can be there is a standing wave. So it seems like you need, I don't know, less than 0.01% precision to know the beam and, calibrate that out some way. Like one thing is obviously you want to know the foreground sky very well, but it seems like it is almost impossible to do UOR and cosmic dawn with SK based on that. And also like there is a discussion going on Starlink. but they also emit some sporadic emission, which is like properly not Faraday caged. Like many instruments are not Faraday caged properly. So, like will Elon Musk company guarantee that then future Starlink satellites they will properly, do a proper Faraday cage or not? Like it seems like most of the radio band are going, like becoming inaccessible in future, and that is what we see in Chime also. Like almost 400 megahertz band, we are throwing 70% of our band, and it is also true for the low frequency cosmology. So yeah, I think both these things are more important, I guess, in next decade. Like, is it possible to do 21 centimeter with SK, or like we are losing hope with that? Like that paper actually shows that all your K perpendicular modes, K parallel modes, above wedge, inside wedge, all are gone just because of this cross coupling effect.
Okay. Yeah, I mean, this is a big challenge, I agree, but I'm sure things are not depressing as you say. But I also then wanted to move to the next point. So just to wrap this up, the feeling I'm getting is that there's no doubt that there's a lot of avenue for synergy and collaboration between the two communities. But I think we are not at a position that those synergies can start like right away. So it probably needs one more meeting, Suman. Just note it down. We need a few more.
That is exactly what we were aiming for here, so that we leave these middle ground open, so that we have to come back again. And the organizers did it so well. I'm very confident they will organize another good conference.
Yeah, that.
Sorry.
All thanks goes to the ICTS because they have a dedicated team to organize these kind of events. Yeah. So we did very minimal actually.
No, but okay. We'll talk about it later, but I think Suman did a very wonderful job organizing the whole thing. Yes.
You're coming to your second point, or?
Yes. So we can go to the second point, and which has to do with like collaborative research. So basically building pipelines, simulations, and all these AI ML algorithms we heard about. So I think various groups are working on them individually. Does it make sense to really collaborate a bit more and be more ambitious in that sense? Please, yeah.
Yeah, I think I can be very brief on that. Then that is something I think we realized over a very long time. So that many people put a lot of effort into developing a pipeline, or developing parts of a pipeline, or developing something. So if we could use that manpower somehow in a more coherent fashion to have one common goal, to have a structure, the ideas of what pieces are needed, I think we could be much further ahead in having I don't know, extremely efficient, well-tested pipeline. So I think what we realize is that a lot of pipeline development is necessary to have high dynamic range, to flag all RFI, to do all these kind of things what are necessary, and machine learning is coming, makes it much better. The question is how to organize that, and the question is how to decide, okay, that tool is maybe good and that is maybe not so good. What I really like are these SKA data challenges, that you put out something and you say, that is a problem, and now different groups can show how well they can tackle that problem. And I think that is useful if you have that for RFI flagging, if you have it for others, so that one can say, maybe, okay, so these are, let's say, the best horses in the stable to put on to work with it.
Yeah, agreed.
Maybe I can. Oh,
so moving, shall we just go through them? And moving on to Ruta, who is like really into pipelines.
Yeah, unified effort is definitely important. So calibration and flagging, definitely these aspects are common to both the data analysis communities, although they may be pursuing it with somewhat different approaches. Any tools that one may develop using AI, ML, or some unconventional calibration techniques The main thing that will matter for SK is actually scalability of all these for very large data sets. We do need to use the test beds, precursors and pathfinders to come up with these methods and test them as much as possible. And definitely the SK software is not going to be written all from scratch. It is based on the experience with these precursors and pathfinders. So definitely there's still a lot of room for creativity in optimizing these algorithms to make it work for SK. And yeah, I think that is definitely a common ground for both cosmology or
Yes,
continuum
yes.
communities. Yeah.
Yeah, and then Carol, I mean, I remember you people having this radiative transfer comparison project, which was a very nice teamwork, and somehow we never followed that up with all these models which are coming up to do reionization.
Yes.
Till this data challenge, which probably will do something similar. But do you see like more scope of collaboration between the simulators?
Yes, definitely. I mean, it's actually, so it will be interesting to see what comes out of the 3B data challenge, where in principle it's from a corrupted 21 centimeter power spectrum. The teams are asked to predict the mean ionization fraction. So I have no idea what the answers will look like, but I wouldn't be surprised if it's all over the place, which basically means that the different methods are not consistent with each other. And they're actually, if you go back, it's actually quite clear, right? So if you go back to the different methods, 21 centimeter fast, the Grizzly, the more approximate methods, they've been compared to radiative transfer solutions, but for one simulation, two simulations, not much more than that. So, and it hasn't really been possible to do this on a larger database, but kind of hopeful to be able to do this soon, actually. But it is necessary because, yeah, as I wrote down, so typically when you use these more approximate methods, you have to include a modeling error.
Yeah.
And this is typically set to, I don't know, 10%, 20%, 30%. But these numbers are just ad hoc. There's nobody that actually knows really what the modeling error is over the entire parameter space. We know what it is for one or two points in parameter
space. It may not be a statistical error, it could be a bias, so you have to really do
exactly.
it.
So there is, actually, we have a small pilot project where we gave a 21 centimeter power spectrum, no noise, nothing, to Brad Gray, who then took it to 21 centimeter TMMC. And it was for 3 phases, so let's say 30% ionized, 50 and 70. And he got the 50% ionized right, but the other 2 points were way off. So there's something happening there.
Yeah, so there's a lot of work to be done in this area. You had something more to add? I mean,
I don't know. Yeah. I think within the 21 centimeter community itself, you can say, I mean, really at the advanced level of the data processing there, different methodologies have been developed, right? So there's HERA, there's LOFAR, there's MWA. They're partly different because they're different systems, but I think in general, you can say there hasn't really been a lot of collaboration there yet. Maybe this will come, because there could be things that we can learn from each other there. And I also, I don't know, should I do question B as well or not?
Sorry?
The AI?
Yeah, please,
okay.
yes.
So yeah, I wrote down, so the development is extremely rapid there. So new techniques come up all the time. So clearly, I think I have the feeling we're very much in the age of experimentation when it comes to these techniques, and we don't yet know, but they're clearly very powerful. I think for working with the radio data, well, also for the simulations, there's a focus on the machine learning emulators and kind of pattern recognition. I mean, the worry there is a little bit that we're using these things, we use simulated data to train them, but can we then use them on real data? Because we don't actually know that the simulations represent the truth.
So regarding the collaboration thing, in the observational perspective, there are two things actually. One is the pipeline and another is the data itself. So I think in the SK, what I heard that SK, the pipeline, all the people will share the pipeline and then one thing, but still SK Pathfinder, that's like what Gal said, that itself the data we have not collaboration with the different communities of the, like MWL for all these things. So I think that will be one of the good thing initiative if we can share with some parts of the data also, so that we can, before SK comes online, we can, our community should already means at least try to match with their results and pipeline also, if the same data is available. So that will be one of the collaboration thing we can start.
Just to understand, you are saying the broader community, if they can access MWL, LOFAR, GMRT, different data sets and apply.
One of the things, the same data, but different pipeline. Or pipeline, same different data. So this kind of things, if we can start, that will be one of the good things we can.
Carry on. You are saying something else? Okay. Okay. So I don't know. First Leon and then Proshun.
I'm usually first. Now on this point A there of maybe the first comment made, right? If we all work together, we would have been further along. I disagree with that. I mean, I think we're in a state that we actually don't know which algorithms are the best, right? I think we need to have many teams that come up with brilliant ideas, and then hopefully ultimately we'll pick the best one, and then we go all work together on this pipeline. So I see a pipeline very differently from this algorithmic and research development in what are the best techniques. And we haven't found the road to Rome yet, so to say, right? If one of these algorithms works and brings us there, right, I'm sure we all jump to it and we'll start using it. So I think it's good to let people play around and have researchers and individuals. We see this in the community, right? There are a couple of people out there in this community whose software is now being used by everybody, right? Because they had the right ideas and implemented it well, etc. So I think letting people play around with it, and you and I have a lot of history in LOFAR, right? In LOFAR, it was told to me, right, 20 years ago, don't worry, Leon, right, we'll reduce the data for you, we'll calibrate to you, and we'll give you the power spectrum. This was told to me 20 years ago. After 5 years that they told me, right, and nothing happened on the whole software side, nothing, literally, I said, okay, right, I don't believe you anymore, right? And even now, right, 15 years later, we've been doing it ourselves, and it's still bloody difficult, right? So I think you really need dedicated groups to look into this and at some point, of course, work together and exchange ideas. And I think we all the time do this at meetings, conferences, but we shouldn't be doing this from the start, I think. That's my personal view.
Yeah, I mean, sorry, taking this forward, I mean, suppose a new group thinks that they have a pipeline to play with. I mean, you suggest that they really start with the absolute raw data from the telescope and start applying, or is there any way to give them somewhat processed data where they can start?
No, I think, I mean, I hope many people, right, I mean, with our data or LOFAR data or upcoming SKA data are going to test their own new algorithms. And maybe they come up with something which works much better than we have or anybody else had. I mean, I'm the first one to adopt it if it works, because I just want to measure this bloody signal, right? I mean, I don't care, right, what algorithm I use, right? I want to measure it. So, right, I'm open for everything. And I think there is cross-pollination between teams, right? We've been using, for example, MWA, particular ways of doing RFI excision, right? They've been using our imaging and also AO flagger, those kind of things. So there is a lot of cross-pollination between the different groups. So I think we should be open.
Yeah, I agree. Yeah, sorry.
May I-
Yeah.
Finally, we have a disagreement over here. Thank you. No, I find I disagree with the disagreement. So I don't want to kill. I don't want to say, okay, somebody decides. So that is now the correct scheme to be used, and that is the only one that makes you imager. So that is maybe that goes in the wrong direction. So maybe I don't manage to explain that in the few minutes over here which are left. I'm a bit inspired, a bit intrigued in a project where we are involved with the high energy physics community. And I think what they develop in terms of tools, which are then useful for these huge collaborations, it is far ahead of what we have at hand in astronomy or radio astronomy. So if you, Ruta talks about scalability, so they have scalable tools. So if they look at the FITS data format, I think they are only laughing. They're okay, you have a data format from the, what was it, 70s or so. If you want to do, have a parallel IO, somebody has to write a data access layer also. And I think, how should I call it? Our people, I think that there are two things which I see. The one thing, they very often start from scratch. Then it's maybe not public, it doesn't comply to a standard or so, but it's already available. And the other thing is maybe that is a political thing. I think that is not a discussion for here. But so in astronomy, we don't have a career path for the software developers. So in Astron, okay, in Astron you can develop an imager and you can have a position over there. But I think in astronomy, it's very difficult to say, okay, I stick for my entire life to learn, I don't know, ChatGPT prompt editor, and then I will, these people are probably much faster in developing the entire SKA pipeline compared to a standard developer. So therefore, I think it should be a bit more subtle. So I was maybe a bit too provocative.
But if they give me the Large Hadron Collider budget, right, I'm more than happy to follow this philosophy.
Yeah, but then we only have one experiment.
Yeah, Yashwant. Yeah.
So I have one comment which is about point B, AIML. And then after that, I have a question for the OR community. I think this is something that we should really take on board. I'm just coming from an international signal processing conference. And, you know, I've done enough traditional signal processing as an electrical engineer. I was surprised to see how dominated an entire international conference was about the use of AIML in every aspect of signal processing. And, you know, so, and I think this is something that we should really watch out for. And what we need to do, which I think we have done a little bit at NCRA, is to engage with the professionals who know how to do this. I mean, I was really impressed that the group in Indore has done it by themselves, which is great. But in many other cases, there are the professionals who know what is, as you know, as you said, that there are new ideas every day. The professionals know which one is the one to follow as the best one. And if we can work with them, I think we can really leverage this. And this has been shown by some people in our group who work with industry and developed algorithms and got results very quickly. Both Yogesh and Divya have done this at NCRA. And I think this is something that as a community, we should really look at seriously and see how we can do this. My other thing is a question to the UR community in this room about how useful the SKA data challenge has really been. Because in the SKO, actually, some questions have been asked about the time and effort that the SKO put into all the data challenges and whether it was really worth it, whether those same people could have been focusing on other aspects related to science with the SKA and whether it will be useful. So it'll be nice to hear. I guess that thing is still going on, right?
Yeah, but we can hear from the champions of 3A, I guess.
Because what I saw in the earlier ones, that it was a good learning ground for the youngsters, but does it really help to shake down the actual algorithms or not?
I think so, but let's see. Yeah.
So yeah, I think it's a first step. I think it's interesting to have this kind of challenge, but I think SKO running it was a bit maybe a bit complicated for them. They spend a lot of time on it, and it was not perfect. And I think in the long run, we need to have more of this, which include more effects that was not included in this one. So make it a bit more realistic. But that need to be run by our own working group, I think, from the EWA Cosmic Dawn working groups that know a bit more how to make this this simulation a bit more realistic.
So you are saying rather than SKO doing it, it should be left to the, it should be kind of delegated to the science working groups. And that would make it more like realistic and more interesting to work.
I think also from the perspective of 3B, the impression is that it was this, I mean, it's useful for the community. The question is, couldn't we have organized it ourselves?
Yes.
Probably yes. But maybe we needed SKO as a catalyst, let's say, because, but it was definitely very useful for the people within the SKO to learn about our science, which hopefully in the end will be beneficial for the whole thing. Because, yeah.
Okay,
Leon and then Proshun.
Comment that, of course, we did organize a challenge some years ago.
Foregrounds, right?
For no, also the power spectrum and everybody was all over the place then as well. So I think this was one step more realistic because I think in those days we didn't have the feasibilities. Basically, nobody used the feasibilities in those days. But everybody was all over the place. So it really tells you that many of the algorithms out there are certainly not yet mature enough to be applied to real data, or as close as you can get to real data, so to say. So we have done it, and I think we should do it again in the future.
Okay, let's hear from Proshun, and then I will come to you.
Yeah, sorry. I mean, we are discussing about pipeline, but at some point you should realize that once the SK comes in with enough number of antenna stations, then we will see new challenges which we don't know at all right now. And our pipelines has to adapt those challenges. Like Leo said that 5 years we will get the power spectrum and it's 20 years you have not got yet. So once the SK comes, I think for all these data challenges, etc., so we should fold in those informations before we can understand and make the pipeline better. And there's another point, which is that it is not that I mean, maybe we are at a point where different groups can make different pipelines or different algorithms, but at some point they should discuss and figure out that which one is the right way to go, or which two are the right way to go, and then go forward and branch out from there.
Yeah.
Because otherwise it will probably be a too difficult and complex challenge, such that one group can start from somewhere and then end up actually completing the entire thing.
Yeah,
So
so I
do you
can
have
share
some-
our experience about the 3A.
Yeah.
So we have tried actually divide two groups, one the visibility based and image based power spectrum. So what we found that whatever the pipeline we are using, we can't finish for the visibility based. So we thought that we'll submit two results, but finally we managed to complete only one, the image based thing, which is computationally cheaper compared to the visibility based. So that is the learning we have learned. So we have to, means if we have to finish within the time, we have to make it more efficient. So that is the lessons we have learned. Me and Arnav was the, yeah, so that was helpful actually, this as a community.
Okay, Asif, then Arpan.
I want to just highlight one point that we can have different pipelines. I mean, that will also help us to cross-check different detections when we will make the 20th century detection eventually. So this is just the one point that different pipelines can also help actually.
So it's not like we throw away all the pipelines and just stick to one. It's better to have 2, 3 independent pipelines throughout.
We may not need only one pipeline, one best pipeline, but maybe different pipelines can also be used from the same data to do cross-check.
Yeah, okay, interesting thought, yeah. Arpan?
Just a comment on that why different telescopes have different pipelines. Because the problems are different. If you're building a telescope at L-band, you don't have ionosphere. You're building low-far, you have ionosphere. So the person who is designing the pipeline at L-band will not think about ionosphere, who is designing at low-far. So I think that's one of the primary causes. Let's say you have different resolution, you have shadowing. In the other instrument, you don't have. So you don't take care of it. That's what I think is one of the reasons that why you have different pipelines. And that another aspect would be the pipeline is a global term. And inside of that, there are many aspects which are developed independently by many different people. Let's say imaging. 20 years ago, you used to CASA, and someone thought that you can do W-term correction much faster. So that guy wrote that imaging portion quite efficiently. So many people find interesting many parts of that pipeline and want to contribute to that. So so it's not a single component that needs to get modified and checked. That the components itself are quite interesting and to think about. So just comment.
That's fair. Yes. Okay, Nitya.
Have a idea or a suggestion for the EOR data analysis groups. There are different approaches that are coming out. And my suggestion is that each group, as they get better with their approach, at least adopt analyzing the same data with a different approach as well in parallel that can be considered in some ways truly independent to their own. So that way they can see, I mean, they may not be even comparable because the approach doesn't really apply to the kind of data format or data redundant versus non-redundant. So we don't know yet, but at least adopting this approach means that you will understand better what the limitations are, what the gaps are, where the synergies are. And that gives more opportunities for cross connects between those different approaches. And also there is an internal consistency that you're doing by taking an independent approach. You're more confident in the result as well.
So we are almost coming to an end. So quick short
Maybe just
comments.
a quick reaction to this. So some people in my group and in NWA after the SKA meeting in Germany are staying on a bit longer to look at each other's software and also look at, right, I mean, whether we could use, maybe some LOFA data through their pipelines and the other way around. So it's actually an initiative of people in the group, younger people, not me, right? I'm no longer young. And I think it's very good that they're doing that and open for this. And so it is happening. Yeah.
Okay.
So, yeah, I thought I could make a point about pipelines and algorithms. So on the one hand, I guess we're looking for getting out the right result. So it's like functionality. But the big issue also for SKA is performance. So there are things that we already know how to do, but if we scale that to SKA dimensions, they no longer work, or they work too slow to be practical. And so there is, I think, still a lot of work to be done on this performance side. Yeah. Would be interesting if AI machine learning could actually contribute there.
Yes.
And that I don't know if people are working on, but yeah, could be an interesting angle to explore.
Yeah, I'm sure we could go on this, but I think we need to wrap up now. I mean, we have crossed 5. And so I think this part was, truly interesting. I think there is a lot of value in independent groups trying to develop their pipelines. And at some point, as Leon is saying, if they talk to each other, then figure out the deficiencies, maybe combine them, and again, maybe go ahead independently. So there is and I think we are doing reasonably well here in both the communities in this regard. So there's a lot to look forward to. So maybe, I know it's not very easy to end such a discussion, but for time, I think let us end here, and we'll try to kind of summarize this and share with you and see if we can take this forward. Yeah, thanks Chandrasekhar for doing this, and yeah. So this concludes this panel discussion session. And again, I thank all the panelists and all of you for being here and participating in this. Thank you very much.